Hi everyone, welcome to the Earth Science Regions Review podcast series created by Homix Middle School Earth Science Department. Today we're going to focus our attention on some of the biggest storms on the planet, hurricanes and tornadoes. Now these storms have a lot of similarities, but they also have some differences. So let's talk about both of them, and we'll kick this off with talking about some hurricanes. Low pressure. Low pressure is always going to be associated with bad weather. A lot of moisture, a lot of precipitation. Low pressure always has counterclockwise winds. Those winds always blow inward, and sometimes these storms are actually called cyclones. So these storms are going to drop a tremendous amount of precipitation on large regions on the planet. Now hurricanes have a couple different names. Sometimes they're called cyclones, sometimes they're called hurricanes, sometimes they're called typhoons. Now each one of these storms actually gets alphabetized names attached to them, okay, based upon their location, whether or not they're going to be found in the Atlantic Ocean, the Pacific Ocean, or the Indian Oceans. Now, hurricanes cover gigantic regions. Specifically talk about the United States, they might cover the entire southeast part of the United States, okay, because they can average about 600 kilometers from edge to edge. These storms are going to form over really warm waters, approximately 27 degrees Celsius. So these temperatures have to be above really about 80 degrees Fahrenheit for a lot of evaporation to take place. One fear that scientists have is if global warming really takes into effect and really affects the ocean waters, that the more evaporation takes place, some of these hurricanes that we've seen, like Katrina, could actually get stronger and bigger with bigger amounts of precipitation and even stronger winds than we've ever seen. So we consider the water vapor the fuel of a hurricane. As long as there's water vapor in the atmosphere coming from the oceans, those hurricanes are going to rage on. So these storms actually start off as what's called a tropical depression. Then they get a little bit more organized, they turn into a tropical storm. Once those wind speeds get above 75 miles per hour, then we start getting into the category values to our hurricanes. Now you can see you can go from category 1 to category 5, with obviously category 5 being the most catastrophic. What's not on this visual here is that you can also talk about barometric pressure, how the pressure decreases with each one of these storms. Remember, low pressure is always going to be bad weather. The lower the pressure, the worse the weather is going to be. So hurricanes, again, are going to form over warm water, approximately 27 degrees Celsius. So that's going to be a location right around the equator. It's going to be some of the warmest water. Now, our hurricane season is between July and November. Now, because water has a high specific heat, it takes a long time to heat up. So once that water gets heated up in the late summer, that's going to be carried over into the fall. So that's why hurricane season extends well into November. So hurricanes are going to lose their energy basically when they make landfall, when that water source gets cut off, okay, when that moisture is going to be removed, when that evaporation is going to cease, and that energy is going to be lost. That's when hurricanes can lose their power. That doesn't mean that they're going to not contain a lot of precipitation, which they do, but the wind speeds specifically will drop dramatically. Okay, they'll also lose their energy when they move over colder water. A lot of hurricanes move up the east coast because the westerly wind belt is going to move them east, and what will happen there is that these hurricanes will lose energy because the evaporation isn't as prominent over colder water. So here's some hurricane characteristics. Obviously the classic spiral shape, that's Hurricane Katrina. The typical path of a hurricane, the northeast trade winds are going to take them west, then they're going to hit the east coast, and what will happen is that they'll be start to get carried by the westerly wind belt or the jet stream and start to kick east over top of the Atlantic Ocean. You obviously see some damage here at the NASA station. Obviously homes are destroyed, lives are destroyed from hurricanes. Tornadoes. Big similarity, low pressure, counterclockwise winds. You're going to end up getting winds that are going to blow inward, and again, these storms are also called cyclonic in nature as well. Now tornadoes, okay, big difference here. Hurricanes can last for weeks at a time. Tornadoes last for a very short period of time, matter of minutes in some cases. Another big difference, their wind speeds are actually double that of a hurricane, over 300 miles per hour. Another big difference between a hurricane and tornado, these storms are much more local. They're going to hit a very, very small region because they average less than 1 mile in diameter in terms of the storm size. So these storms tend to be much, much smaller, but at times can be much more devastating. They're measured by what's called the Fujita scale, by an F0 to F5, and that's based upon wind speed and the amount of damage that these storms actually impose on a specific region. Now, The biggest location in the United States where this takes place is Tornado Alley. Basically, this is a location where continental polar air mass comes down from Canada. Maritime tropical air mass is going to come up from the Gulf of Mexico. What's going to happen here is that they're going to mix. They're going to mix really in the early spring. This is when the north is still cold, the south is starting to warm up. And what happens here, there's no natural barriers. There's no mountain ranges to stop these air masses from mixing. So the central part of our country is what we call Tornado Alley. What doesn't help here also is to the west of Tornado Alley, you have the Rockies. To the east of Tornado Alley, you have the Appalachian Mountains. So it almost acts like a funnel and allows these air masses to mix, and you end up getting major, major outbreaks in the early spring in the area that's shaded in that visual. Now, just some tornado characteristics. Obviously, you're going to get some very imposing cloud formations. They're called cumulonimbus clouds. And off the bottom of those clouds, you're going to end up getting your funnel clouds. So just another viewpoint of what some of these clouds might look like. You end up getting big hailstones because of the constant updrafts and downdrafts from these storms. You can obviously get objects flown about. The majority of deaths come from getting hit by objects. And this is kind of a unique picture of a vinyl record impaled in the side of a tree. Obviously, there's your classic funnel cloud. And finally, the last thing we just want to talk about is tornado and hurricane safety. And a lot of this just comes into common sense. Listen for announcements on your local radio stations. You obviously want to stock up on all necessary supplies, batteries, radios, water, fill the bathtub up with water, have a lot of canned goods on hand if you live in areas that are susceptible to tornadoes and hurricanes. Obviously, you want to have a car that's filled with gas. You want the gas tank filled up. Obviously, have some extra money in case you have to evacuate your area. And obviously, you want to go down. You don't want to go up because a lot of these storms will rip homes off their foundations. You want to go to the basement. And obviously, watch for falling objects. You want to stay away from glass by all means because these big winds will blow windows out. You don't want to get cut. Watch for those falling objects as well. So with that being said, hopefully you'll do well in your next exam with tornadoes and hurricanes, and we'll talk to you soon.